81 light-years from Earth, there's a planet that shouldn't exist. It orbits the corpse of a star, a dead, Earth-sized ember that was once a full-blown sun. And it's so close to that corpse that it whips around it once every 34 hours. Here's the problem: before a star like that dies, it swells into a monster hundreds of times its original size, devouring everything around it. Anything sitting where this planet sits today should have been swallowed, melted, and torn apart. And yet, there it is. Intact. Calmly circling the star that should have destroyed it. Scientists literally call that region the forbidden zone. This video is about the only known planet living inside it, and about the unsettling secret it carries regarding the future of our own solar system. The story begins in 2020, when NASA's TESS Space Telescope was doing what it always does, staring at thousands of stars at once, hunting for the tiny dips in brightness that give away a planet crossing in front of them. Normally, these dips are minuscule. A planet like Earth blocks less than 1/10,000th of the light of a star like the Sun. But when astronomers looked at a faint white dwarf in the constellation Draco, catalogued under the decidedly unglamorous name WD 1856+534, they saw something absurd. Every 34 hours, more than half the star's light simply vanished. This wasn't a subtle transit. It was an eclipse. Something enormous was passing in front of that star, and when they ran the numbers, the answer made everyone deeply uncomfortable. The object was a gas giant the size of Jupiter. And here's the detail that breaks everyone's intuition: the planet is roughly 7 times bigger than the star it orbits. Sit with that for a second. A planet larger than its own sun. A giant spinning around a point of light smaller than itself, less than 2 million miles away, 50 times closer than Earth is to the Sun. To understand why that's so bizarre, you need to know what a white dwarf is, and what a star does on its way to becoming one. A star like the Sun spends billions of years burning hydrogen in its core, a stable nuclear furnace that keeps everything in balance. But that fuel runs out. And when it does, the star panics. The core contracts, the outer layers balloon outward, and the star transforms into a red giant, a bloated monster that grows to more than 100 times its original size, swallowing entire planets like dust. In the WD 1856 system, that phase of fury consumed everything out to roughly the distance of Earth's orbit, maybe farther. Afterward, the star blew its outer layers off into space, forming a nebula that slowly drifted apart, and all that remained was the exposed core, a white dwarf. A stellar ember the size of Earth, so dense that a teaspoon of its material would weigh tons, glowing faintly, no longer producing any energy at all, just cooling forever. It is, quite literally, the corpse of a star. And that's what WD 1856b orbits, in a region where, during the red giant phase, it would have been vaporized in short order. So the question that has haunted astronomers since day one is easy to ask and brutally hard to answer: how did it get there? The answer science has pieced together, bit by bit, reads like a movie script. The planet wasn't born where it is now. It didn't survive the star's death from the inside, it watched it happen from a distance. When the red giant swelled up and devoured the inner system, WD 1856b was sitting in a distant, safe orbit, probably dozens of times farther out than it is today, watching its star die in agony, hurl its own guts into space, and collapse into a tiny, pale point of light. And then, long after the funeral, something pushed it. The leading suspects are violent gravitational interactions. Maybe other planets in the system traded gravitational shoves until one of them got flung onto a plunging orbit. Maybe the 2 red dwarf stars that accompany the system at a distance slowly warped its path over eons, through a relentless effect astronomers know well. Whatever the mechanism, the planet plummeted toward the stellar corpse, and the white dwarf's gravity, tiny in size but brutal in strength, tamed the giant's orbit, rounded out its trajectory, and locked it into that tight 34-hour embrace. A survivor that, after the tragedy, moved closer to the grave, and stayed. And that's where this story picked up a brand new chapter, because the James Webb Space Telescope turned its instruments toward this world and pulled off something unprecedented. It directly detected the infrared light coming off the planet itself. In 2025, that measurement revealed that WD 1856b has an average temperature of 125 degrees below 0 Fahrenheit, officially making it the coldest exoplanet ever directly observed in the history of astronomy. A frozen world, bathed in the ghostly light of a dead star, colder than the darkest Antarctic winter. Along the way, Webb also settled an identity crisis that had dragged on for years. The new measurements showed its mass is no more than 6 Jupiters, confirming once and for all that it's a planet, not a brown dwarf, that in-between thing that's not quite a planet and not quite a star. But 2026 brought the most stunning discovery yet: Webb detected methane in its atmosphere. That might sound like a technical footnote, but think about what it means. It's the first time in history we've observed the atmosphere of a planet orbiting a dead star. And that atmosphere told a secret. The planet is warmer on the inside than it has any right to be. There's an excess of internal heat that the white dwarf's feeble light can't explain, and when scientists ran the models, they landed on a fascinating conclusion: that heat is a scar from the journey. The planet would have been heated during its violent migration, and the math points to that happening roughly 1 billion years ago. In other words, we're not just looking at a survivor. We're looking at a survivor that still carries, in its own body, the warmth of the journey that saved it. And this is where the story stops being about a point of light 81 light-years away and starts being about us. Because in about 5 billion years, the Sun is going to do exactly what WD 1850 SIXS star did. It will burn through its fuel, swell into a red giant, swallow Mercury, swallow Venus, and, very likely, swallow Earth. Then it will cast its outer layers into space and collapse into a white dwarf the size of the planet it just destroyed. For a long time, scientists wondered what would be left after that. WD 1856b is the first concrete answer: Jupiter, Saturn, Uranus, and Neptune can survive. And more than that, they can migrate. They can drift in toward the Sun's corpse and end up in orbits that would be unthinkable today. This planet is a photograph of our own system's future. And it cracks open an even more provocative door: if a gas giant can migrate that close to a white dwarf and settle into a stable orbit, a rocky planet can too. And white dwarfs, dead as they are, keep radiating light and heat for billions of years, enough to sustain a small habitable zone around them. Which means there may be worlds scattered across the galaxy right now, warmed by dead stars, quietly orbiting stellar corpses in systems everyone had written off as finished. The death of a star, long treated as the absolute end of a planetary system, might just be a new beginning. In the end, WD 1856b is more than an astronomical curiosity. It's proof that the universe doesn't follow the script we write for it. A planet that watched its own sun die, weathered the gravitational chaos that followed, plunged toward its star's grave, and instead of being destroyed, found a new equilibrium there, spinning, frozen, and serene around a light that already died, carrying deep in its core the heat of a journey no one witnessed. Somewhere in the constellation of the Dragon, it's still out there, completing a lap every 34 hours, a quiet reminder that even after the end, something always survives. And if you made it this far, drop a comment: if humanity is still around 5 billion years from now, where should we go when the Sun begins to die?